Okay, so we are talking about the midterm. So midterm will be on Thursday. There'll be 10 questions, each worth 10 points. There will be a combination. I probably won't have you write a lot of code in C#. It's possible. Like if I asked you to do something programming wise, it would be kind of short type stuff. Like I might say, assuming there is assuming the script is attached to a game object, write the line of code necessary for getting access to the rigid body of that. So, this dot get component rigid body with the angle brackets, just to, how do you extract programmatically something from Unity into the script? So it would kind of be one line type things like that, as opposed to asking you to write code that does like logic stuff. All right, so there would be kind of minimalistic programming stuff like that. Now, I would very likely show you code. Like I might say, assuming this code is in the update method, what does it do? Something like that. So you should be able to explain to me this happens every single frame, and this is what this does. It checks for collisions or checks for user input, whatever it is. So I would expect you to be able to read more complex code. Remember, my policy in my classes is that if you do poorly on the midterm, well, regardless of how you do in the midterm, if you do better on the final exam than you did in the midterm, I'll replace your midterm exam score with whatever you get in the final. So if you do poorly on this one, it's not the end of the world yet. All right, so what I'm going to do is I'm going to go through our slides here and kind of talk about the concepts that I think are fairly important. This is the process I'll go through when I write the exam. I'll basically walk through these slides and try to come up with questions related to the things that I think are important on these slides. So I'll go through this and tell you those things now so you can focus your studying. Let's see. You should be able to tell me what a game engine is. I would probably say that might be a last resort type question, but be able to describe kind of the historical context that, older games, we used to have to write all the physics, all the math, all that stuff that kind of every video game has. And the purpose of a game engine is to have a lot of that stuff built in because physics hasn't changed. Gravity hasn't changed. So it has all that stuff built in so we can focus on writing the game logic rather than writing a bunch of the physics and collision stuff. Okay. So know our typical vocabulary stuff. What's a scene? What are kind of the different game objects that we've worked with here? So a scene is going to be a collection of game objects. Now, up to this point, we haven't written anything that transitions between scenes, right? We will write something in the next game that transitions between scenes, but a scene is kind of its own little self-contained entity, and if we transfer to another scene, we're going to have to solve that problem of, if my character currently has a certain amount of health or something like that, and we move to another scene, I need to now get that character over to the new scene with the same amount of health so he's picking up where he left off or something like that, if that makes sense for your game. So know what a scene is. Obviously know what a game object is. Be able to tell me about transforms. If I ask you what's the most generic game object, what makes something a game object, it's going to be that it has a transform, right? What's a transform? It's a collection of 3 vector 3s: position, scale, and rotation. Okay. And then it can be a collection of other components. So I might ask you, what's a game object? Tell me about transforms, and then give me at least 2 examples of components that can be part of a game object. So what would be a couple of examples of components that a game object might have?
Rigid body and mesh collider.
Okay, so rigid body, mesh collider. We can have an animator. So we have that stuff in the newer game. We have had scripts. Okay, scripts are a component associated with them. Anything else we've had associated with our game objects? Certainly materials. Have materials associated with them. Which then means if there's a material, then there's also a mesh renderer that comes with it for some kind of renderer. So various options for that. I would probably at most ask you to give me 2 examples or something like that of components that are part of a game object. So there's your material component. Know what that is. Know about the purpose of a material component. This allows us to give a color or a texture to a game object. We've used it for color, but in the directly, but in the game you've been creating, I think you used a texture to put in there. Actually, we used the texture in the pumpkin one too. Yeah, for the floor. So certainly know what a rigid body is. So a rigid body is how gravity works, and it's used for supporting collisions from a mass perspective. Okay. But collisions actually occur between 2 colliders. They don't require a rigid body, but if you want something to have the physics act on it, rigid body gives it mass. So understand the concept of scripts, going even deeper into scripts, understand the differences between, so if we like open up our scripts here, understand the differences between awake, how we might use awake, what kind of things we might put in there, what kinds of things we might put inside of update. Now we haven't actually used fixed update in here. I think we saw it as an example at some point, but a fair question might be the difference between update and fixed update. Remember what the difference is between those two?
Update like is a cap, and then fixed update is like set to like 60 frames per second compared to like whatever your computer can do with your graphics card.
Okay, and why might somebody choose to use fixed update rather than update?
Or like everyone has the same, like no one's like better than another person based on their computer.
Yeah. And maybe the idea of no one isn't necessarily fair, because if your computer can only do 30 frames a second, then you're starting off at a disadvantage. But the idea is that it creates an equal playing field, or at the very least. So that's one example of where fixed update could come into play. If you're trying to create an even playing field and you don't want one person who can potentially have things change more often, have a visual advantage. What's another example of when fixed update might make sense?
I think I'm not your example, like the bosses that game you're talking about, like they started coming out a lot faster than they would because they were putting updates.
Yeah. So that has more to do with, that's like a really poor example of update, right? If you're actually doing it based on so that particular game I was talking about, Double Dragon, they seem to time when monsters would come out based on number of frames. So if you have a really fast computer that can do, you have a really fast graphics card that can pump out the 4,000 frames between spawning really, really quickly, then you'd have all these monsters on the screen at once. So fixed update only gives us the thing of having it limited to 60, but any way you cut it, you probably wouldn't want to link spawning to number of frames. I suppose if you've limited it to 60, you probably could. You probably could use fixed update for counting and do it based on a number of frames and just do the math to kind of create your own timers. But it seems like it would be a pretty poor use of fixed update. Can you give me another example of when fixed update could be beneficial? It's related to performance.
It's not as much like it doesn't take as much performance to like use it versus like trying to do it as fast as it can. It only has to do it at 60 frames a second.
Yeah, so you might have certain things that, it doesn't have to happen exactly every frame. You might want to cap it at happening 60 times per second. Asking questions, things like that. Maybe wanting to know, did a collision occur? Or maybe wanting to know maybe you're checking the position of something on the screen, something like that. For example, we had our pumpkins despawn when they fell off the screen at a certain point, right? That way we didn't just have 4 million pumpkins spawned and falling into oblivion, right? Now, did we really need to check every single frame to see if the pumpkin had hit a certain, negative on the Y? Or if we just check that 60 times a second, is that good enough? Whether or not the pumpkin disappeared 2 frames later or not the end of the world, right? So we picked up some performance there rather than having to check every single frame. So that's some examples of good uses of fixed update. Sometimes it's not just about creating an equal playing field. Sometimes it's also about asking questions as often as you need to ask questions, right? What if you want to ask questions even less often? How would you, let's say you didn't even want to ask it every 60 times a second. What if you wanted to ask it every 1 second? Let's use the pumpkin as an example. Was that good enough? Just right off the bat. Is it good enough to say every 1 second we're just going to ask each pumpkin, have you fallen off the visual screen? And if you have, let's kill you off. Is every 1 second okay for that?
Probably.
Yeah, we're not dealing with, we're just trying to we're controlling the total number of pumpkins that are in existence at any point in time. And if we're, culling our pumpkins every second, we probably could even stretch it more than a second, but certainly every second is fine. We don't need to do it 60 times a second. How would you accomplish that? Let's say you were doing it every 1 second. So this might be kind of an example of a question I might give where I give you a scenario and ask you to explain to me how you might solve it, where there might be multiple reasonable answers. And then there's some bad answers. So how might you solve that if you want to check every 1 second? Nothing? You got nothing for me? Okay, but we're still checking that. I assume you want to put that inside of either fixed update or update. So, okay, so let's pause the question for a second. We're going to keep going through the slides, and I think we're going to hit the answer. So as soon as we hit the answer, you can tell me that's what you would use. All right. Effectively, what I'm asking you to do, if we abstract it from the specific question, is how do you build your own sort of update method that you control how often it gets called? That's kind of what I'm asking, right? All right. So we talked about frame rate, certainly understand that, but really more in the context of that update and that fixed update. I probably am not going to, I guess it would be fair game to ask something like, what is a frame? And when something is operating at 60 frames per second, what does that mean? Something like that. You should understand that concept that a frame is effectively a single still image, and 60 frames per second is showing me 60 still images in a row in 1 second to make me feel like it's fluid motion. Something like that. I don't know if I'll ask that, but that would be a fair game type question that would, certainly be there ahead of other things that I haven't said at this point. All right, so we kind of talked about in class that this was kind of thrown out the window, right? I think you pointed out that some of the stuff you had read indicates the human eye is better than my dated information was. So this is kind of a bad slide. I think there's a partial truth to how many frames per second the human eye can mentally process, but they had all sorts of tests with pilots and stuff saying that they could tell a difference between a much higher frame rate. So that means they can detect it. So I won't ask anything about that since I don't have a great number for you anyways. So we just talked about this update versus fixed update. So certainly know the difference there and be able to give me examples like we just went through of when you might use each. I might even ask you for like a fixed update to give me a kind of a specific example. Give me some sort of maybe controls. For instance, this kind of goes back to the equal playing field thing. If we want players to only be able to change their direction 60 times per second, for example, that way you don't have one player who happens to have a really high frame rate able to kind of react quicker in actuality. If he turns left or something like that, maybe we want to detect that. We want to ask the questions about 60 times per second as opposed to every single frame, because now you might potentially have somebody with a really good card able to be more agile. They can move quicker on the screen, even though we're talking about fractions of a fraction of a second. It still might be something, right? Even in that same argument, though, you also have to play the game of, I don't know what the thing is here, but would it be possible so let's say we're talking about jumping. So you maybe use the space bar for jumping or something like that. And maybe we say, well, a player should only be able to jump. We want all players to be able to jump at the same rate. So we're only going to check to see if they've jumped, press that button 60 times per second, right? Would it be possible for somebody to hit the space bar in between those checks? I feel like the answer is no. I don't think that somebody could. We certainly can't hit the space bar 60 times per second, right? But is it possible for us to hit the space bar and between pushing it and letting go of it, it was within the window between 1/60th of a second? You see what I'm saying? Where you actually missed the jump because that wasn't part of the check. We checked again. You actually pressed here in the middle. I'm feeling like that probably isn't possible. I think that the time it takes us to depress and let go is more than a 60th of a second. So something like that might be, maybe you have your controls limited to a 60th of a second just because that then gives you an equal playing field. Certainly the concept of MVC, I almost guarantee that's going to be on the exam in one form or another. What is MVC? What does it stand for, and what does it ultimately mean? I care less about what it stands for, much more about what it ultimately means, but I'll probably ask both.
It's a good idea to separate your code from your interface.
Okay, so keep your code one place, your interface in another place. It actually also talks about where you should keep your data in the official MVC thing. But it basically says have your stuff in multiple places. So we have our scripts and we have our Unity interface, right? And then that ultimately translates into we need to have some sort of mechanism for these two to talk to each other. How do we have these two to talk to each other in Unity? How do we have our interface become aware of things in our scripts? And how do we have our scripts aware of things in our interface? How do we make those things connect? Let's go one direction. How do we allow our interface know about something in our script?
Making something public.
Yeah, so create a public field, then Unity's interface knows about that particular field, right? Okay, so that's that direction. How do we allow a script to know about something from the interface?
You grab something from a player object.
Yeah, so get the component. So our ability to take the game object that owns the script and ask it to give us one of its components, give us its rigid body or something like that. So we have a way of going both directions for gaining access to things that are in these separate places because we've decided it was a good idea to design our interface over here and write our logic over here. Make sense? Anybody remember what MVC stands for? Yep, model view controller. So model view controller. And keep in mind that MVC, this guy is an example of a design pattern, right? So design patterns are a proposed good solution to a common problem. It's a generic idea. Model view controller happens to be an example of a widely accepted Very widely accepted design pattern. But keep in mind that model view controller is not a implementation. It's an idea, right? It's a design pattern that then can then go and be implemented by different systems. So what you just described to me is Unity's specific implementation of MVC. If you're in the 250 class, we're going to be starting Android programming next week, and you're going to see Android's implementation of MVC. How does it accomplish kind of the similar type thing where your interface and your code can talk to each other? And I mean, it's going to feel kind of sort of ish the same, but you're going to see it is different, their approach to it. All right, that makes sense. One form or another MVC is on the exam. So that's a promise. So there you go. One question's under, at least one question, might even be two. Okay, really important concept. Even though it doesn't seem like it's that big of a deal, this concept here is going to benefit you throughout your entire computer science career, because every single modern technology that you develop in will have an implementation of MVC. Okay, so understanding that concept and knowing when you go to learn a new technology, saying, how do they implement MVC here so I know how to make interface talk to code? All right. Certainly understand the concept of colliders. I might ask you, like, what's the difference between like a capsule collider, a sphere collider, and a box collider? What would you say? What is the difference between those three different colliders? Okay. Fine. How does that translate out? Okay, so like the points where it can collide, right? So a box collider is going to be like you're hitting a box. So if you bump into it on this side, you have that entire vertical surface that you can collide with. Where a sphere collider is going to be curvy, right? So you can bump it here in the middle, but higher up and lower, you have to go in farther before you hit it because the sphere is curved. Capsule collider is kind of our we might say it's our common way of representing kind of a humanoid, because it kind of looks like a person when you kind of consider core body. If we, in a lot of games, you might not want to get to the granular level of like, did we bump our thumb into something? Because consider that, well, maybe I asked that question. I mean, that might be a reasonable question on an exam. Why is it that in a video game, we might not want to have colliders all over everything? We might, for a humanoid, we might choose to have a capsule collider that handles their core, but we don't put little capsule colliders on their fingers. Why is that? Why do I not want to have 30 colliders on a single game object?
Well, like if we go back to like the pumpkin game, if we had like our hands outstretched or something, and like we hit a pumpkin, that could be like off screen almost, it doesn't look like realistic in terms of like playability, in terms of like.
Yeah, it might make the game suck.
Yeah.
Is kind of your point, right? I mean, there's one thing about being like super accurate in real life. If somebody's throwing, blades at us or something like that, and it clips our thumb, and we're gonna know we got colliders. We got colliders on our thumb in real life. Okay, but maybe in a video game, we don't have that granular control over those individual pixels of our bodies. So it almost creates maybe a poor gameplay. Because now you're bumping into stuff. You ever played one of those games like, I did not hit that? You're like yelling at the screen. Okay, but you like definitely hit it, right? Well, actually, you probably hit it based on the accuracy of their collider, like how well it fit into the body. So like we've seen, if you're having a capsule collider, you make it just a little bit too fat. So it technically goes maybe an inch outside your body. Then you might think you missed something, and you really did, but from the game's perspective, it hit. Okay, but really, that's actually, I was going to say the better answer is that, but that's a good answer. I mean, we do have to, as a game programmer, we have to think about not necessarily what's the most accurate to real life, but what's going to play out in terms of the best gameplay. And since in real life we have very granular control. In fact, one of our senses, it's outside of the five senses actually, is that we have a knowledge about where any part of our body is at any point in time. I forgot what it's called, but there's a thing like, no matter where you put your hands, you know where your thumb is relative to your body. It's kind of some extra sense thing. But in any case, as a human, we have a lot of control over those things. So, we might move our hand out of the way so something doesn't hit our hand. Where in a game, we're limited by how our controls are created, and any way you cut it, it's a more simplified control mechanism than our brain's ability to control all of our limbs and things like that. So it might make the game suck, having too many colliders. And then you pointed out, probably the more obvious is performance. Okay, if we have 4 million colliders on a person, well, that's a lot of extra error checking, a lot of extra, checking for collisions to occur at all sorts of little pixel points around the player. So kind of an interesting thing. Now we kind of do have a catch-all collider. Anybody remember what the catch-all collider is? It comes with I think as soon as you add I'm pretty sure as soon as you add a rigid body, this collider gets put on. A mesh collider. So can you tell me, we really haven't talked about it, but can you tell me, just for completeness, I don't think I'll ask you questions about mesh collider, but can you tell me what can you tell me about mesh collider? What does it allow us to do, and what doesn't it allow us to do?
I think if you put it on the floor, it allows it allows pathing with some games, it takes the surface of that object as a collider instead of making a shape within the object to collide with.
Okay, yeah. So it works with individual points across. So you think of it like a net that goes over something. So it's going to be much more granular in terms of all the points where something might hit. So it doesn't only have to be. You can, if you had a 3D object you created in Blender, for example. So you made your own 3D object. You can put a mesh collider on there, and it would wrap it. Now, as you point out, that could cause some performance issues. That seems like it's almost as bad as having a whole bunch of colliders, right? Because you have all these points now we have to worry about. Well, one of the things that it does for mesh colliders, it treats mesh colliders differently than it treats our traditional capsule and box and sphere colliders. It's doing a lot less individual checking and not applying physics to it because all the individual points that might get hit. So it does allow you to ask questions about whether a collision occurred, but it won't apply physics to those collisions because the performance would suck. It's kind of the idea. So if you need to have physics-based collisions, you would build, some sort of, collider system on either throw a capsule collider on it, or if you want it to be kind of humanoid with the arms out like that, we'll throw Christian worldview in here and make it a cross, have a cross collider or something like that. But then your arms don't move like this. This is your collider. All right, so I won't ask anything about mesh colliders, but just as an interesting thing, because we see them often because they automatically get tossed on when we throw a rigid body on there. Because earlier I had mentioned that rigid bodies also support collisions. When I first introduced rigid bodies, I mentioned they support collisions, but the rigid body isn't the component that supports the collision. It's the mesh collider that comes with it that supports the collisions, but at a no physics level. All right, but I won't ask anything about mesh colliders, but certainly know about capsule, sphere, and box colliders, which are all identical other than shape, right? Okay. Certainly know what a vector 3 is, XYZ collection. We did talk about this more recently, and this would be a fair question to ask. And I'll hit it again here in a few minutes. But the idea of pass by value versus pass by reference, what kind of value is a vector 3? Is it an object or is it a struct? So this almost goes back to our history of our programming languages. We went from C to C++, then to Java. That's as far as I need to go for this example. And when you learned about the transition between C++ and Java, one of the big things there is that, and we could say C# is the same thing, but but C# brought a couple of things back. But when we went the transition from C++ to Java, one of the things, if Java had like a main goal, it was to remove a lot of the stuff that always happens, make more decisions for the programmer, instead of letting the programmer have granular control over all these little things. And one of the things that Java did is they removed the idea of something called a struct. Anybody remember what a struct is? We use them quite often in the game programming stuff. So structs and objects are kind of sort of similar to each other. We can almost think of a struct as being the precursor to an object. So a struct is a collection of name-value pairs. So if you've had Python, it's like a dictionary, okay, from our Python courses. But historically, a struct is a collection of name-value pairs. So you can have a single variable type, that's type struct, and you can have a string for first name, a string for last name, an int for age, things like that. So you can have a bunch of name-value pairs that aren't necessarily all the same type. But what a struct doesn't let you have is it doesn't let you have embedded functions. We can't have methods associated with those fields. So we can look at a class, an object, as being kind of the upgrade to a struct, where we have a collection of name-value pairs that we call fields. And then we can also have a constructor, and we have methods that we can put in there that operate on those fields, right? So that's kind of the upgrade for an object. So do we understand the difference between those two at that level, struct versus object? But what's more important for us in this example is these two. So Java kind of mistakenly made the decision that, we don't need a struct, because what is a struct? It's an object that we choose not to write methods in. Because if we just take an object, take a class, and just put fields, name-value pairs in there, and then don't write any functions, we effectively have a struct, right? But only almost. Why do we only almost have a struct? What's the difference between a struct that holds a string first name, a string last name, and an int age, and a class that holds a string first name, a string last name, and an int age?
That's by reference, or
yeah. And that if you are a new programmer and you're not used to seeing structs, which commonly we're not. We've seen we use structs here in C#, but we haven't referenced them. I've used the word a couple times, but we don't reference them as structs. And we're actually using something built into something that uses some older libraries. Like Unity has adapted a lot of old C++ libraries to, like, vector3s have been around forever and ever and ever. All right, so if you're a new programmer, you're just learning how to program today, the last couple of years or something like that, and your first language is Java or even C#, chances are you might never use a struct, because you're just writing object-oriented programming. You want a class, you write a class. Your class does what it needs to have. So the idea from your perspective is, classes are always passed by reference. If I pass an object into a function and I change that object, that's permanently changed, because what I passed was not a copy of the object. What I passed was the original, the real deal. Structs, though, are passed by value. They're passed the same way as primitive types are passed. So if we pass a struct into a function and we change it, when we come out of there, we see a modification. Does that make sense? I'm sorry. When it comes out of there, that change that we made had no side effect. It was not modified. So if I had a struct here and I pass that struct into a function, a copy of that struct gets sent into this function. I can make all sorts of changes here, and the original remains the way it was before. So as soon as this function's over, that copy disappears, it's garbage collected, and the original is what it was before. So we do need to be careful about that if we have a function that we pass a vector3 to, and we change the position of something, like its transform, then it comes back out, things won't be updated on it. Does that make sense? Now, we've recently seen an example of this, right? When we were using the Raycast. What was the example where we had to force a pass by reference? Remember that with the Raycasts? Yeah, we had an out keyword where we had a struct called hit. that was passed in. I forgot the actual the struct type of it, but the variable name was we called hit. And it was by default passed in by value. We chose to treat it as being passed by reference by putting the keyword out in front of it that says, I want to get the results of changes to this guy. Does that make sense? Okay, so it's important for us to understand it. And really, this has very little to do with C#. This has much more to do with modern game engines are based off of older game engines. So, when Unity came out, it was basing itself off of, Unreal Engine and even the game engines before that, which were almost entirely built in C and C++. And even behind the scenes, Unity is likely heavily built in C and C++. They've chosen, why do you think Unity's chosen C# as their scripting language? Presumably the application is written in C and C++ for performance, right? Why have they chosen C# as their scripting language? Say this again? Yeah. If you took 100 programmers today, and you asked them, what their, let's say, favorite language is, even though I teach from the perspective that your favorite language is, that there's no such thing as different languages, right? They're all programming is a skill set. The language itself doesn't really matter. If you took 100 programmers and asked them what their favorite language is, you're probably going to get a high incident of Java and Python. C# will be up in that argument as well. You might get a couple of Swifts from the Apple fanboys, something like that. You're not going to hear very many C's and C++. Make sense? Okay, because those 100 programmers were trained to program in the last 5 or 10 years. 5 or 10 years, that's Java, Python, and C#, depending if you're doing .NET stuff, whatever. Those are the languages you work with. Those are the languages you're familiar with. And for those of you who've had, none of you have had the 450 class yet, right? Yeah, so the 450 class systems programming, we use C++ here. So when you have that class, you'll see that, it's not that big of a deal jumping to C++. It's just, at first it's kind of quirky because they're making you do all this extra crap you're not used to doing because it's an old language. But in general, it's the same thing. The language will feel the same. So you'll recognize that idea that those older languages really aren't problems, but because you're not familiar with them, and even a traditional computer science program these days might not even teach C and C++ anywhere in there. It might not even be part of the curriculum. They might just go with, hey, here's the languages you're going to need to get a job. But even though, if you look at the most popular programming languages, C++ is still a top fiver. Why do you think that is? Why do you think C++ is still one of the top 5 most popular languages? In some circumstances, you'll find some industries might still use C++, but in general, that is going to be a dying. Anything new that's being built, it's probably fair to say that 99% of new development is not in C++ or C. It's going to be in one of those more modern languages. So why C++? Okay, because you might be maintaining older software. Okay, so I've talked about it before. My wife's a computer programmer. You know what language she codes in? COBOL. Old. Ancient. In fact, it's a major problem in industry today. There's a high demand for COBOL programmers because they're dying. Literally dying. The folks are becoming elderly and dying. We don't have a COBOL class, right? It's very, very uncommon. Maybe even, I don't want to say it doesn't exist anywhere, but it's pretty uncommon in a college for them to have a COBOL class anymore. Good thing is that, again, programming is programming, so you can pick up COBOL fairly quickly. But we have a lot of these old pieces of software that still need to be maintained using older languages. And C++ was a very, very, very popular language for a very, very, very long time. There's a lot of code out there that still works that people are writing. Trivia question, does anybody know what, there's a specific kind of genre in technology industry that would still use C++ pretty heavily. Anybody know what that might be? What area would you maybe do new development using C++? Where's that 1%? Embedded systems. So it's becoming pretty common that, we have little tiny microprocessors and, like your dishwasher has a tiny embedded system in it for handling its cycles and stuff like that, right? Those are little programs, that handles, like, we're going to do the get everything wet, spray everything with soap, do the scrubbing action thing, and then rinse everything off and then dry everything, right? That's a program that runs those cycles. Well, those, so why do you think those are, the code on those are going to be written in like C++? What's the advantage of a language like C++ over one of our modern languages like Java and granular control over memory? Because a lot of times it comes down to the memory that's going to be on that microprocessor, the memory that's going to be on the embedded system. So it's kind of a computer on a chip type thing they put in there. They might be able to get a 32 kilobyte one for, let's call it 10 cents. And they might be able to get a 64 kilobyte one for 12 cents. Well, from a single consumer perspective, we're like, 2 cents for double the capacity? Why not? Well, if they're building thousands and thousands of these things, that adds up, right? So they're going to say, well, since I have more control, I'm going to get the 32K system on a chip and control the memory myself to the point where it'll fit, as opposed to maybe using a more modern language like Java, where you don't have much control at all over how automatic garbage collection works and how fast it works and things like that for getting rid of memory that you allocated and no longer need. Okay, so those languages are still beneficial in embedded systems because we're still operating against the constraints of low memory. We don't live in a world today where we have to deal with low memory because memory is inexpensive from an individual consumer perspective. But when something's being built in bulk like that, we might artificially create a constraint on memory for cost. Make sense? Okay, but punchline from this is understand the idea of pass by value versus pass by reference. Understand the concept of a struct. Vector 3s are structs. So these guys are passed by value. So, the generic definition of a design pattern, I doubt I would ask you that specifically, but like I said, MVC will definitely be on there. So there's MVC again. Know what a transform is, how that guy works. It's a collection of 3 vector 3s, and it's what makes a game object, the core component of a game object. We started talking about arrays. So we've had collections of our, I think we did this with our spawn points. I think for our, the pumpkin game, where we had spawn points, we created an array of those game objects, right? Drug all the spawn points in there, and then used a random number generator to randomly select one of the buckets of that array. So understand the concept of an array. It's a collection of like elements, similar to a Python list, exactly like a Java array. Like I said, I'm not going to have you write a lot of logic code on this exam, so I doubt you'll have to use an array yourself, but pretty high probability one of the, if I give you an example of an update method, I might have it go through an array or something like that in there and say, what does this code do? Okay, so this idea of instantiate, what is this guy used for? What did we use instantiate for?
Create an object.
Yeah, so our first example of that was with the pumpkins, right? So when we spawned a pumpkin, what we did is we created an instantiation of a prefab. So we one of the parameters that came into our script was a public game object, called pumpkin or pumpkin prefab, whatever we wanted to call it. And what we did is we dragged the, is it drug or dragged? Dragged. We dragged the, you always go with definitely wrong, and then you're, so we took the prefab for our pumpkin. What's a prefab? Yeah, it's like a reusable, pre-configured, prefabricated game object. So we drug our prefab from our prefab folder into our script so that we kind of had that blueprint for which we could instantiate new copies of pumpkin game objects. Make sense? So there was multiple versions of instantiate, but the one that we dealt with took 3 parameters: the game object we wanted to instantiate, where we wanted to put it in the scene, so a location, which would be a vector 3, and then the rotation we wanted it to start at, how we wanted to rotate it. So 2 of the 3 transform elements, right? I think there was another version of instantiate. They allowed us to pass it a whole transform, but 2 of the 3 transform elements are what we passed it because presumably your prefab has the scale set correctly already. Otherwise, it's not a very good prefab if the scale's wrong. All right, so we used instantiate to create a new game object. So programmatically add a game object to the scene at runtime. Make sense? What's a quaternion? Whenever you see the word quaternion, what should be the first thing that pops into your head? Rotation stuff. Okay, so crazy math that handles rotation. Coroutines. Tell me about these guys. When will we use a coroutine?
We don't want to put something in update.
Okay. Why wouldn't we want to put something in update?
So it's not as much like performance, like it's not as much of a performance hit, so it doesn't like try and do it every frame or every 60 frames.
Mm-hmm. Now, what's the first line of our coroutines? Every single time our coroutine has a first line that does what?
Creates indirectly.
It waits. So a coroutine allows us to create a timed type situation, right? Remember earlier I asked how do we create our own update method? We want something to happen every 1 second. Could we call a coroutine, tell it to wait 1 second, check to see if the pumpkin has fallen below a certain thing, then call that same coroutine again? Wait a second, do it again. Make sense? So coroutines would be a mechanism that we could use to create our own different cadence update-like function. Make some sense? Okay, and they run inside their own thread, which means that they are happening, for our thought pattern, we would say they are happening at the same time as update or a fixed update, but these guys are not linked directly to each other. So our coroutine is not being affected by update getting called multiple times per frame, because one of the things we've talked about being careful about is putting too much stuff inside of update where it can't finish in a single frame, especially on a really fast computer. You got to put logic in there. We can't put logic inside of update that's going to take, a half a second, because by that time you've already had 50 frames fly by. So that same code's gotten called multiple times. All right, so coroutine is very important. Will probably be on the exam in some format. Might even be on the exam 2 different ways. There might be a question asking you to tell me about a coroutine and maybe giving me an example of how one could be used. It might also show up as an example, like if I show you some code and ask you, what does this do? You should be able to see a coroutine, know what a coroutine is when you see one. And understand that wait function says wait for some amount of time, and then all that stuff. What does it mean for a call to be blocking? For example, that wait function is a blocking function.
So, like our example, I guess, was when we it seems every example is complicated, but like when we respawn, we didn't want to like die immediately, so we like blocked the glider from being hit from anything.
Right. So, so a blocking call would say that it's something that prevents more logic from continuing. So it acts like a wall, right? We're stuck on that line until that line lets us pass. We would not want to put that inside of update because update gets called often, right? So there's another example of where we might spin off a coroutine without the intention of calling that coroutine a second time, right? Maybe we don't create our own little update-like function with a coroutine. Instead, we call a coroutine once, wait 2 seconds, so block for 2 seconds, and then kill off the golem or whatever we were doing. Yeah, I think that's what we were doing. Respawning the golem. So that would be an example of it, but we do it inside of a coroutine because that's how we can get that blocking code without blocking update. We want update to keep doing its thing. Okay, but we put this coroutine which runs in its own thread separately, and we block in there so it doesn't block us here because this is in its own thread. This guy is in its own thread, and this one's the one that's being blocked. That makes sense? So blocking calls are going to be an important part of how we create logic in our games. It'll find its way on the exam in one form or another. All right, questions about that? Tagging. What do we use tags for in game objects?
Group like item or object.
Okay. You tag a prefab. Well, give me an example of how we might use a tag. Maybe that's going to be the easier way of.
In your script, if you're talking about a certain object, let's say you're talking about the player, that group has tag player, and you can say in the script, like do this to player or the object tag player, and then do that object.
Okay. So maybe the place where we've seen the clearest example of using tags is dealing with collisions, right? So, we might be interested in whether a collision has occurred, but maybe more importantly, there might be 3 or 4 different objects that can collide with each other in the scene. And maybe we only really care about, for instance, our player colliding with a pumpkin. Okay. So our code's going to get called. So remember we have that function on collision enter. Right? So that code's going to get called every single time any collision occurs. Inside of that, we might put an if statement. We're going to ask a question because we're a little concerned about what collided with what. We only are going to do something here if our player collided with a pumpkin. Okay, because we're going to be getting that function called pretty often when our player collides with the ground, for example, or when the pumpkin collides with the ground. Make sense? So we can use tags to identify the type of object that is involved in a particular logic, and a good example of that would be with collisions to deal with whether a certain something collided with a certain something else. Make sense? All right, so that's what tags are used for. Destroy kills off a game object. I probably would not ask you that as a direct question, but it's possible it'll find its way into one of the code examples, like what does this code do? And maybe the last line of it finally destroys a game object or something. So you should know what it does, but I probably won't ask you to just define what the destroy function does. It's fairly self-explanatory. What does it mean for a collider to be a trigger? As you just read the slide. That's okay. It's like built-in studying, right? What does it mean for a collider to be a trigger? The second we hit that box that says is trigger, what immediately have we turned off? Physics. We've turned off automatic physics. But look, when trigger is on, no physics. Okay, we're reading it right here. If you're going to sit there and stare at the slide, at least read it. All right, so if we hit is trigger, we're turning off physics. Why would we want to turn off physics? And maybe the better question would be, or the same question would be, why would we want to use a trigger?
Turn off aspects of the game.
Well, triggers are specifically related to colliders, right? So when physics is on and one object collides with another object, physics takes over and those guys, they bounce off each other depending on mass and all this stuff like that. We would use a trigger when we want to programmatically handle the idea of a collision. So for instance, we use triggers when the golem was, we saw the example of this when the golem was colliding with the pumpkins. Because otherwise, what happens? The pumpkin smashes into the golem and kind of knocks the golem off kilter. Because remember, we had the golems, we had him locked on rotation and stuff, but he was falling backwards or something like that. One of our examples. But you know, when you have these two objects and they slam into each other, physics is occurring, right? Unless we make that collision, one of the colliders, a trigger. Actually, if we want, they can both be triggers and they won't affect either. You know, both sides will not be affected. Isn't that funny? Like when I unplug this thing, it shows me all the stuff it blocked, yet it's showing me a whole bunch of stuff here, right? This is just popping up thing after thing after thing. Why randomly now? It's garbage. Computers suck. You guys have to invent the next, the better version of this crap. Yeah, so we would use triggers when we want to programmatically handle stuff associated with a collision. Maybe, you know, that's when we do the respawn stuff for the golem and that kind of stuff. Maybe we don't want a visual physics-based impact, but we do still want to programmatically handle it. Okay, this is that thing. What's a game object? So the generic form of what a game object is, if I ask you that question, which I could see this question being on the test, you know, give me what is the most generic form of a game object? Okay, it's a transform, which is 3 vector 3s containing position, rotation, and scale, and then 0 or more additional components. Okay, we talked about the pass by value versus pass by reference. Renders, what's a renderer used for? When a renderer is on, what happens? We see stuff, right? we see stuff. So if an object, game object, has a renderer, it shows up on the screen, right? We visually see it. If we turn that renderer off, we no longer see it. It doesn't mean it's left the scene. It just means that we can't see it. And it also means that it's no longer, when we turn the renderer off, it's no longer interacting with other objects. All right, Raycast. You know, this is something we've dealt with more recently. So this can be used for a collision, but it allows us to take a starting point and basically cast a beam of light, you know, almost like one of those little laser pointer things. So cast a beam of light and deal with collisions along that cast, right? We specifically used it in our second game here to deal with mapping mouse clicks to movements, right? Because you have a 2D screen in front of you, but a 3D environment. So when you click on the screen here, we had to, you know, do a raycast through the screen down to where it actually interfaced with the terrain to give us the point in 3D space that we wanted our dude to move to. Make sense? Okay, so raycasts are used for that. It'll probably be on the exam in some form. Character controller. So this guy, I'm going to go a little quick here since we're low on time. So character controller, this guy we used for our hero in the second game. So this guy has a whole bunch of built-in stuff for movement and stuff like that that's pretty common across all games. It also gives us more granular control over collisions. So almost kind of the halvesy approach. We talked earlier today about not wanting to have a zillion different colliders, because having a zillion different colliders is going to hurt our performance, but we also might want to be more granular than one collider. So this guy allows us to ask, kind of, did we get hit on the top? Did we get hit on the bottom? Where did we get hit? That might be meaningful to us. So a character controller allows us to Has a lot of built-in stuff that that's already been solved for a player in a game, so we can again focus more on the gameplay. All right, character controller will probably find its way onto the exam in one form or another. This is, I think, where we were, because we didn't talk about masking in here, right? This is a 325 thing. I definitely talked about masking. Did we talk about it in here? Because we did have the ands in here, right?
Yeah, we'll talk about
The places where it could hit the collider. Okay, yeah. So I'm not going to ask you about the details that are under the hood with masking. So with that in mind, I probably won't ask you about masking specifically in here. But I might ask you about this bitwise thing here, this bitwise and, that allows us to ask a question whether a collision was on the top and on the sides or something like that. I maybe wouldn't ask it as a direct question, but it might be something that finds its way into like a code example when I ask, what does this do? All right, that makes some sense. Observer design pattern. I do like design patterns, so there's a decent chance that guy will find its way on there. So this has to do with more like, let me know, send me a message when a certain event occurs. All right, so know about that guy. Animators know about the idea of a state machine. I'm not sure how I would ask that question, but you should know about the animator, you should know about the transitions, and you should know about the parameters you can create for animators. We talked about variable passing, polymorphism. That's a 250 thing. I want to say these might be 250. Yeah, these are 250 slides. That's where I said earlier in class that I put some stuff. So these aren't our slides. I have to get those copied over to 250. All right, so that's everything for the exam. Questions, comments, concerns, bribes. All right, so you'll have the full time to take the exam next class. I usually write the exams to be for a 50-minute class. So it should not be a time constraint, but sometimes I write a bad question that does take longer, but hopefully it's not a problem where something takes more time than you have. All right. I will see everybody on Thursday. And keep your eyes open for my HDMI cable laying around the department somewhere. It's a blue cable.